All right, so let's talk part B. Here's the model that they've given us. A equals 15.7 e to the 0.0416 t. I don't think I mentioned this in the previous video. Now, this rate, that's the growth rate, okay? So even though it's a decimal, and even though it's a relatively small decimal, that population is growing, right? Okay? By small amounts, but it is getting larger. So when this is a positive number, we know that it's growth, okay? And more specifically, this is the rate as a decimal. Remember that we can always turn our decimals into percents by moving the decimal point one way or the other, okay? So technically, since this is the decimal, the percentage would be if I move this 2 spots to the right, it'd be 4.16%. So the rate at which the population is growing, and I know it's not asking for that, but understand this is the decimal value that talks about the rate, but as a percentage, we can move that decimal 2 spots to the right and get 4.16%. So that's what this number represents. It's the growth rate, or the percentage value that the population is growing by. So in this question, part B, it says, when will the population? Emphasis on that very first word, when, right? When is a question talking about time. So when it says, when will the population of the state reach 18.7 million, okay? How long will it take? When? Asking the same question. They're asking us to solve for time. So that's our variable in this equation now. And then we've got to put 18.7 million. They want to know when's that going to be the population. Well, it says that the population is represented by A, right? And we said before that whatever this whole thing is equal to here, that's the population after some period of growth. So they're saying this population is going to grow to be 18.7 million. That can go here. How long is it going to take for that to happen? Okay, so here we go. We got 18.7 equals 15.7 e to the 0, blah, 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 blah. All right, now I'm solving for this. I need to get at that variable. And more importantly, I need that variable to be on the first level of the problem, not up here in the attic, right? Okay, we've been solving exponential equations up to this point, and you realize that the only way we can solve for a variable here is by using a logarithm as an operation. Okay, so we're going to quote log both sides of this equation. But we can't do that until we've isolated the power. So the first goal in solving an exponential equation like this is isolating this power, getting this by itself, which means we need to get rid of 15.7. So since 15.7 is in front of this, they're pushed together, that's multiplication. So we're going to divide by 15.7. We're going to divide by 15.7 here as well. So we get this canceling. We have just our power over here now. Okay? And 18.7 divided by 15.7. I think I've got a Desmos window queued up here. No, that's my email. Desmos 18.7 divided by 15.7. We'll call that 1.191. 1.191. So we've got this. Now, typically, I would tell you this: don't round until the very end, but I don't want to write that entire thing out. Okay. So now we have our power isolated. We can solve for t if we get it knocked down onto that first level. And the way that we accomplish that, as we've seen over the last couple of days, is to log both sides. Now, when I have base e, I'm going to use natural log. So I'm using a logarithm as an operation that undoes this variable exponent and knocks it down in front. So that's going to be the natural log of 1.191. This power now comes down on the first level, like so. And then we have the natural log of t. And in fact, why don't I keep this whole thing in parentheses? Yeah. So that moves down in front. I've got this natural log of e. Let's talk about that. What's the natural log of e? Right? 1. We should know that by now. So what am I doing here? I'm multiplying this times this. And if this has a value of 1, okay, I'm multiplying 1 times this quantity. Anytime you multiply something by 1, you get that same value, right? So now my equation looks like this. How do we solve for t now? We divide by its coefficient. Okay, so what I'm going to show you once I jump back to Desmos here, hopefully you'll be able to see what I'm talking about. This is the calculation. I know there's a lot of stuff going on. This is the calculation that's going into Desmos. Okay, these are going to cancel. So now our equation is just t equals. When I jump back here to Desmos, I know I abbreviated this decimal at this point, but because I have that still saved in my calculator here, here's what I'm going to do. I'm going to do the natural log of 1.1. I'm going to use the entire number that shows up on top, and I'm going to divide that by 0.0416. I get approximately 4.2. Okay? So we'll go with approximately 4.2 years. Alright? So it's all about getting the power by itself first. It's all about isolating the power and then logging both sides. Right? And then we just got to get rid of that guy.